comes up a lot and people forget about it. So in a 10-team basketball league, that means in the league there are 10 teams, correct? Each team plays every other team twice. So not this team but that team, this team but that team. That's not what it means. It means every other team besides themselves twice. Okay? So each team plays every other team besides themselves twice. Once at home, once away. Okay? So if they play each other twice, we can actually use home and away blanks. If they play each other anything more than twice, we are going to have to use combinations, which we'll do later. Okay? But if they're playing a home and an away, order matters. Because home and away means order matters. It means that one you're at home, one you're away. And if you don't believe that home and away games order matters, ask someone who's played a sport. A lot better to play at home than it's away. So home and away does matter. Order matters. Okay? So how many teams with this is there? 10. Can we go 10 and then 10? Because then that would be them playing themselves, correct? Are they allowed to play themselves? So it'd be 10 then 9, which is 90. What you could do is okay, there are 10 teams, and I pick 2 to play at a time, correct? This 2 represents how many play the sport at a time. So soccer, hockey, basketball, volleyball, sure, a lot of sports, lacrosse, would have a 2 here, because 2 teams play together. It would have to be some special, like soccer there is a soccer that you can play 3. I don't know how it works. But then it would be a 3. There'd be 3 teams playing at once. Okay, that's what the 2 represents. The 2 doesn't represent the home and the away. The 2 represents how many are playing. The P represents that this home and away exist. It gives it an order. Okay, so this is 90. So this only works if we have them playing each other, a home and an away game twice. Okay. That was yesterday. All right. In a competition, on the back of a cereal packet, 7 desirable qualities for a kitchen, example, spaciousness, versatility, etc., must be put in order of importance. The number of different entries that must be completed in order to ensure a winning order. So they're putting how many qualities? 7. And they're lining up all 7, or just 3 of them, or 4 of them, or 5 of them? Does it specify a shorter amount of them? No, so they're doing all 7, right? So, and it says they have to be completed, entries must be completed in an order. Must be put in an order of importance. And then that order gets you a winning order, right? So, how many options do we have for the first play? 7. So this is the absolute amount, maximum amount that you would have to actually draw in order to get a winner. If everyone had to put in a different looking ticket, right? So there'd be 7 qualities for the first blank, but then I would leave a quality behind. So then there would be 6 then, 5 then, 4, 3, 2, 1. I could write this as what? 7 factorial. Or I could, because we're going down by 1 each time, I could say I start at the number 7. P, how many blanks? 7. All of these, I think it's 5,040. Yeah. Okay, now we're going to do restrictions and repetitions. Now repetition means that still order matters, but if I have the word boo, and I tell you to close your eyes, and then I go boo, you're like, nothing changed. And I'm like, dude, I swapped the O's. Super changed. Did it change the word though? No. So we have to get rid of those cases where I swap the O's, but it actually doesn't do a difference. Okay? So let's discuss how we can go about that. So consider the stuffies example from last lesson. We had a kitten, a puppy, and a bunny, right? There's 6 ways to arrange those 3 stuffies. So we had the previous one, we had 3 for this one, then 2, then 1, and we got 6. We agree? We had a kitten, a puppy, and a bunny. We had 3 different stuffies. So what would happen if instead of having 3 different stuffies, so that was last example, we have 2 of the exact same kitten and 1 puppy. So you can't tell the kittens apart. Not one's been played with more, so it has a floppy ear or something. Like, they look exactly the same. Okay? How would this affect your answer of 6? So let's try and draw them out. So we have 2 kittens that look exactly the same. If they didn't look the same, we could go kitten 1, kitten 2, and then we could tell the difference between them, correct? But they look the exact same, so we have kitten and kitten. Like, no difference, right? So let's arrange them. We have kitten and then puppy. Then we swap the kittens. Kitten, kitten, puppy. Wait a second. They're not different, correct? What else could we do? Kitten, puppy, kitten. I'm going to swap those kittens again. Kitten, puppy, kitten. Oh, they're not different. Right? What else could I do? Puppy, kitten, ooh, kitten, kitten. Then I could swap the kittens. Puppy, kitten, kitten. Oh, wait, it's the same. So instead of 6, how many did I get this time? 3. So there's got to be a way we can do this without having to list like 1,077 examples. We did like 3 little objects that were easier, right? You agree? So the way that you do this is I treat it like letters. So I say kitten, kitten, puppy, and I stack letters. So the moment I stack letters, because they match, I'm going to have to get rid of situations where they're the same. And how do I do that? So on the top, I treat them like they're all different. So I still do my 3 blanks in the numerator. I'm going to have a numerator and a denominator now whenever I have anything repeating. In the numerator, I treat them like they're all different. So in the first blank, how many stuffies could sit there? In the first blank? 3. Then, how many in the second blank? 2. Then 1, which gets me 6 in the numerator, correct? Now, instead of like trying to like cross off the cases where they all look the same, which would take forever, the way to fix the problem is you just divide by factorial, however many numbers that are doubling or tripling. So in this case, I have 2 k's. We agree? So in the denominator, I'm just going to go 2 factorial. What is 2 factorial? It's 2 times 1, correct? Which is just 2, which gives me an answer of 3. Does the work for you? That is the only difference. If you have repeating objects, you have to factorial the repeating objects in the denominator. You treat them like they're all different in the top, and then just divide by the factorial, and poof, you fixed all your problems. So it's not like people that get repetition and freak out. I'm like, no, it's exactly the same, just factorial on the bottom. That's all you have to do. It's nothing crazy. Okay? So let's look at this next one. In the mountainous regions of India, China, Nepal, and Bhutan, it is common to see prayer flags. Each flag has a prayer written on it, and a color is used to symbolize different elements. Green, water; yellow, earth; white, air, wind; blue, sky, space; red, fire. How many different arrangements of the same prayer, so it has to have the same prayer, can you make using all 9 flags? So you have 1 green, 1 yellow, 2 white, 3 blue, 2 red. They're identical flags. So what I always do when I get identical things is I write them out and pretend they're letters. That's what I do to make my life easier. So I have 1 green, like the word G, letter G, and then 1 yellow, 2 white, 3 blue, and 2 red. I have the word Huber. It's a great word. Everyone likes it. Okay? Now whenever you get words, you will always do what I'm doing, because if you stack letters, I promise you, stacking letters will actually remind you to do something. And I learned stacking letters from someone I tutored like 10 years ago. They're like, my teacher tells me to stack. And I was like, your teacher's a genius, and I'm borrowing their idea. That's what it is. I don't know what teacher it is, or I give them credit. But what you do is you go G, Y, W, and then I have another W, so I write it below. So I will always rewrite my words and stack the ones that are the same. And the reason why is hopefully when you stack them, you go, why am I stacking these? Oh, right, I have to divide by factorial for those because they're the same. Then I have B, 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 R, R. Right? So our denominator then, I don't even do the numerator first. I go to my denominator right away because the moment I've stacked things, I'm going to have a denominator. We agree? So I don't say that I have 7 factorial because I don't have 7 of the same letter, correct? 7 factorial is 5040. You don't do 7 factorial. You're going to do, I have 2 W's. So I'm going to put a bracket. I'm going to go 2 factorial. Then I have 3 B's, and I go 3 factorial. And then I have 2 R's, so I go 2 factorial. Now multiply those out. 2 times 3 factorial times 2. Do you need a factorial if it's actually a 2? No. Because 2 factorial, 2 times 1, which is 2. So it's 2 times 6 times 2, so you should be getting 24. So on the bottom you have 24. If I did 7 factorial, which is all of them, that's 5040. I'd be dividing by a totally different number, correct? 7 factorial represents 7 of the exact same letter. Do I have 7 of the exact same letter or flag in this case? No. Now the top has 9 flags, correct? So how many blanks am I going to have? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is what you need to remember. You treat the top as if they are all different. I know there are some double up and triple ups, but I got rid of that problem by the bottom, correct? So how many flag options would I have for the first blank? 9. Then 9 again. Do I have an unlimited number of flags? No, maybe 8, because I don't have an unlimited number of flags. Then 7, 6, make sure you have the dots. 5, because they mean multiplication. 4, 3, 2, 1, and you get 9 factorial at the top. So do 9 factorial divided by 24. And what do you get? 100. So here it justifies that. The number of permutations of n objects where A are the same of one type, B are the same of another type, and C are the same of yet another type can be represented by this. The total on top divided by that, correct? There could be restrictions. It could be the word Vancouver, and then you have to start with a B and end with an R, and then you can't just go 9, 8, 7, 6, 5, 4, whatever, right? Okay. We'll be dealing with those in a second, but not right at this moment. So it says determine the number of permutations of the word Vancouver. Does it say I start with a B? Start with a vowel? End in a consonant? Middle letter has to be A? Does I say anything? No. So the first thing we're going to do is rewrite the word Vancouver. So let's go. V-A-N-C-O-U-V-E-R. And then you triple check, double check, triple check, that you haven't missed a double up or triple up letter, right? Because sometimes you write an R twice but don't realize you wrote it twice. You know what I'm saying? So I go to the question. I'm like, I don't even care what the question is right now. I need to put a 2 factorial in the bottom. Guys, sorry, I want to bring you back up here for a second. Chillax that. Let's look up here. Say you want to type this into your calculator, and instead of writing this, you write 9 factorial. I want everyone to type this in at one step. See if you get the same answer, because a whole bunch of you will not. So, do you know where the fraction button is on your calculator? Does everyone know where that is? You've been taught it? Do the fancy calculators, like the colored ones, you can go alpha link, and your fraction will pop up. If you have the other ones, you go alpha y equals enter. If you have the TI-83s, it's never happening. You just have to type it in the way it is. Okay? The key thing is, if you do not use the fraction button, you have to type the numbers in brackets. The denominator in brackets. Do you see that? And the reason why is if you don't use brackets, you're going to go 9 factorial divided by 2. Then it's going to times it by 3 and times it by 2, which you don't want to happen. You want numerator divided by denominator. So if ever you want your calculator to know that's a fraction, if you're not using the fraction button, I just always bracket my numerator divided by bracketing my denominator every time. Okay? If you have a TI-83s, I will bracket my numerator divided by bracket my denominator every day, all day. She doesn't have fraction button.
Oh, no, the factorial.
Oh, math?
Yeah.
Yeah. Keep going. You're right. She got you. Okay. Now, Vancouver has how many letters? How many letters does Vancouver have? 9. So remember, we have to count all the letters, even the doubling off ones. So we have 9. So on the top, is there any restrictions on this? Is there any restrictions? Anything like I start with a V, end in an R? No, so we're going to have 9 blanks, and we're going to go 9, 8, 7, 6, 5, 4, 3, 2, 1. So do I have to show that? Or could I just do what? 9 factorial. So if there are no restrictions on the word, you can literally just do the letters factorial over the number factorial, right? I don't know what the answer to that is. You'll have to tell me. I have a really large line. 440? Okay, you do mathematical. Try it out. So we have M, A, T, H, E, M, A, T, I, C, A, L. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So on the bottom I'm going to have in brackets 2 factorial, 3 factorial, 2 factorial. You don't need the brackets to use the fraction button. And then I recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then I can just do 12 factorial, correct? Did I go 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1? Yes. Could I go 12p12? Yes, 12p12 is the same. I start at 12, I go down by 12 blanks, right? 12p12. 12 factorial is actually the same as 12p12. They're the same. What do we get for an answer?
19.
Good reading. All right. Now we're going to get to some restriction-y things. We're going to do example 3. We go back to the word answer. So now, forever and always, I will rewrite the word. A-N-S-W-E-R. And then you feel like an idiot because you just rewrote the word. But that just means that there's no double ups or triple ups. So there's no denominator, right? That's a great thing. So I always rewrite my word. I'm going to tell you right now, the people who do not rewrite their word on the unit exam will often get every one of these wrong because they will forget to divide by the factorials. So you're lucky if there's no doubling up or tripling ups, but if there isn't, they will do the answer. And do you think the answer will be there for you forgetting to divide by the factorials? You think that answer will be on the test? Yep. And it'll be picked more than the right one if you forget to divide by factorial. Okay, so you make sure you do that. Okay, so we want determine the number of arrangements of 6 letters in the word answer. Answer is all 6 letters, okay? No restrictions. I'm going to have how many for the first one? That's 5. How many going to have? 6. Then 6 again, 6, 6, 6, 6. Or it's a word, so I always have to remember to do what? Box and hold. Keep a letter. Yeah. So say I keep the A here. Then I have how many? 5. Say I keep the R here. Then I have 4. Keep the W. Then I have 3. Keep the E. Then I have 2. Keep the, I don't even know what else I have left. N. And then I have 1. I just have the A, R, S left. Which is, make sure you have the dots. 6 factorial, which is 720. You try B and C quickly. Remember, consonants are just not vowels. Vowels are A, E, I, O, U. Try these 2 out quickly. Begin with an S, begin with a vowel, ends with a consonant. That's okay. All right, so answer 1, 2, 3, 4, 5, 6. Has to begin with an S. How many S's are there? 1. Then we have, how many letters left? 5 then. And I'll speak at once. 4 and make sure you have your multiplication dots. And this could be represented as 5 factorial, couldn't it? Which equals 1. Okay, the next one, it begins with a vowel, ends with a consonant. 1, 2, 3, 4, 5, 6. So let's begin with a vowel. So I have A or E as my option, correct? So I have 2. Then I must box and hold 1. I'm going to pick the A because I don't know. I just picked the A. There's no. I love E's equally. Okay. And then the back one can be N, S, W, or R because it has to end in a consonant, which is 4. Which one should I pick? N. So now the A and the N are gone. Could I have picked E and R? Yeah, it just means I took out 2 letters, and I am holding 2 in my hands. Actually, I'm not. They're in the spots. How many letters do I have left? 4. Then, boom. So this could be written as 2 times 4, which is 8 times 4, 3, 2, 1. 4 factorial. So sometimes they write it that way too, right? What's the answer? Okay, then we're going to flip over. Okay, we're talking about this. So adjacent means together, means side by side. We did this yesterday. Remember how we hooked letters together and then we moved them? That's what we're doing. So it says that have 3 letters, A, N, S, adjacent and in that order. So that's A, then N, then S together. Okay? So let's try it out. 1, 2, 3, 4, 5, 6. They can be together anywhere, but if they say together to me, I always put them together with the front and then I move them. It's just what I do. You could be a rebel and do it differently. I would suggest you not, but you could. So I'm going to hook these ones together because adjacent means together, side by side. Now, what option do I have for this first blank? A only. So 1, then N, then S. Now they're locked there, correct? How many letters do I have left? 3, then 2, then 1. And this would be the answer if I said adjacent at the front. Did I say adjacent at the front? No, did I say adjacent? Yes. So then there's cases of where I can move them. Remember how we did this yesterday and we moved the cases? So how many cases are there? Well, there's 1, the one we currently have. Or it's at the front. That's 1 case, correct? Then I could move these between these 2, which is 2 cases. Here, 3 cases. Here, 4 cases. We agree? Did I tell you it's always 1 more than the number after the hooked together numbers, correct? So these ones are the hooked together. What's the next number? 3. So there will actually be 4 cases. It's always 1 more than the hooked together numbers. So if this is a 3, I'm going to end up multiplying by 4. Why? Because it's 1, 2, 3, 4. So we multiply by 4. Now I actually write it as a multiplication of 4, just to prove to you that it's because I'm making 4 cases. That's why I don't do the dot. You can absolutely do the dot, but it throws people off. They think I'm multiplying by 4 letters or something. I'm multiplying by the 4 because there's 4 cases that will give me the same answer. Okay? So this is 24. How is this one different? That have 3 letters, A, N, S adjacent, but not necessarily in that order. So I still have 1, 2, 3, 4, 5, 6. I still have them adjacent. Not necessarily in that order means how many do I have for here? 3. Because it could be A, N, or S, right? Then I hold one of them. Then I have 2. Then I have 1. How many letters have I used up? 3. How many do I have left? 3. So now I have 3, 2, 1. And what am I going to multiply it by? 4 cases, correct? 1, 2, 3, 4, or 1 more than the number hooked together. So now I actually have, now please pay attention, I lose people here. This is where everyone gets lost. It's the way I write the question. So 3, 2, 1 is what? 3 factorial. And then what's this? 4 factorial written out of order, correct? 3, 2, 1, 4. So that's the same as 4, 3, 2, 1. See what I'm saying? So it's 4 factorial because of that. I don't know why sometimes this is just color. This 144.
Yes.
If you look at example 4 is the exact same questions. Exact same questions. What's the difference? Read the first sentence. Read the example 4. Determine the number of different arrangements of the 6 letters in the word and sweet. There's doubling letters, right? So we're going to do everything the same work. We're going to do the same work, but we have to make sure that every single one of them has a denominator of 2 factorial. Because we have to rewrite the word. A, N, S, W, E, A. Correct? So every one of these, I'm going to have a 2 factorial. A 2 factorial. 2 factorial. Do you see I'm not even reading the words? I still have to go back and read the words. But my point is, people are like, when do I not do the 2 factorial? Never. You have to. Okay? So, try these out. See how you do. Get them wrong, no big deal. Without restrictions, we would just have the 6 factorial like we did before, because it would be 6, 5, 4, 3, 2, 1, right? So instead of 720, we'd have 360. Begins with an S would still be the same because the number of S's didn't increase. So we have 1, 2, 3, 4, 5, 6. We have 1 S that begins with it. Then we have 5 letters left. 4, 3, 2, 1, which is 5 factorial over 2 factorial, or 2, which is 60. Okay. Then, this one we have begins with a vowel and ends with a consonant. So this one's going to be a little bit different because there are now actually 3 vowels, right? The A, and the E. That is 3 vowels. Because we're treating it like we can see the difference between them. Yes? So here we have an A, and an E. It's supposed to be the same letter. So that's 3 options, not 2, right? Box and hold, let's say one of the A's. Then here I would have the consonants, which would be N, S, and W. So now I only have 3 of them. Pretend I hold the N. How many letters have I used up? 2. How many do I have left? 4. So I have 4 for this blank, then 3, 2, 1. Which is how many? 108? Now here it says that have the answers A and S adjacent and in that order. You have to watch yourself though. There's not just one A now. So there's 1, 2, 3, 4, 5, 6 blanks, correct? It says A, N, S in that order. I happen to have 2 A's. So how many am I going to have here? 2. Box 1 of them. N, I have 1. S, I have 1. And they're hooked together. I've used up 3 letters, correct? So I have 3, 2, 1 left. Am I done? I have to multiply by how many? 4, because they have to be able to move, correct? So times 4. So you actually get 24. I don't know why it's switching colors on me. All right. We're going to do A and B. Frank, George, Hannah, Iris, Jacob, Kim. Is there any doubling or tripling people? No, they're all different humans. Okay? So there's going to be no denominator. I want you to do this one. They're sitting in the adjacent seats A3 to A8. So this would be A seat A3, A4, A5, A6, A7, A8. So it's actually 6 seats for 6 people, correct? In how many ways could they sit together? There's no restrictions. So they could be in any spot. Remember, you have to leave a person behind, though, right? It's like setting someone in a picture. You have to leave a person, and then you get to have like 5 more, and you get to have like 4 more, and you get to have like 3, right? And then I want you to do this one. We're skipping C for Monday. Don't do this one. Do not cross it off. We're skipping it for Monday. So try A and B. And then I want you to try example 6. Okay? So A and B on 5. Do not do C. We're doing that one for good fresh brains on Monday. And then example 6. So try them out, please. So for this one, there's no restrictions. So Frank, George, Hannah, Irish, Jacob, and Kim. Remember, you could treat them like the word F, G, H, I, J, K. Could you not? Because you can't repeat them? So we would have 6, then 5, then 4, then 3, then 2, then 1. Or we could write 6 factorial. Or we could write 6, is what I start with, because they go down by 1. P, how many blanks? 6. These are all the same, or I could write 720. Next one says George and Hannah are dating, and how many of the arrangements in A would they be sitting together? So now I have to make them sit together, correct? So 1, 2, 3, 4, 5, 6. I have to make George and Hannah sit together. Does it say George is on the left and Hannah's on the right or anything like that? No. So the first one could be George or Hannah, which is 2. And then I have to keep one of them. So I'm going to pretend to keep George. Then Hannah would be here, which is 1. How many people have I used up? 2. How many do I have left? 4, 3, 2, 1. Now, do they have to be together on the left? Does it say that? So what do I still have to do? Times by how many? 5. Always 1 more than this number. You'll get 240. Then we're going to flip over. This is 2 times 5 factorial. All right. So this one says, determine the number of arrangements of the word Canada. C-A-N-A-D-A. Every word, every single one of these can be divided by 3 factorial. Do we agree? So it must begin with a vowel and end in a consonant. Canada has 6 letters. 1, 2, 3, 4, 5, 6. Begin with a vowel. How many vowels are there? How many vowels? 3. All 3 A's. Remember, we treat them like they're different. Correct? So it has to begin with a vowel. It has to end in a consonant. How many consonants are there? 3. How many letters have I used up? 2. How many letters are left? 4. So I have 4 for this one. 3, 2, 1. So for homework, I want you to do example 6. And that is it. Finish it because we're going to go through the beginning of class and we're going to do the other one.